PRL, whether my screen is visible to you? Whether my screen share is reaching to you? Anybody
Yes.
can?
Yes, yes.
It is reaching to you. Okay. Very good morning to you all. Since yesterday, that is a very strong foundation has been laid about the LIDAR. A fantastic talk by Professor Jayaraman, my guru in the LIDAR. He told a very basic, fundamental, and very lucidly that how LIDAR works, what is the importance of LIDAR, and after that, basically that our Raghunathji and Veera Buddhian, they all told like that about dial, Zaman LIDAR, and other things. And a beautiful talk by John Perry about the satellite observation using the Calypso. So these are just a few names I took. That very strong foundation was made yesterday. So I can say you are all students. I am telling the sitting there. They are a semi LIDAR scientist now, and by the tomorrow when the workshop will end, they will be definitely a fully LIDAR scientist, and they will be in, you can say, in the kitty of the atmospheric science, or you can say LIDAR exploration of the atmosphere, atmospheric exploration using LIDARs. So and today morning talk by Venkat Ratnam, it was so nice. It was covering almost, you can say, the 20 decade, how the LIDAR is filling the much desired gap in the understanding of the lower and middle atmosphere. There was, of course, that things were there, but with middle atmospheric program of India, which was started by our late B.V. Krishnamurti ji and late Subraya Sahab, Subraya ji and B.V. Krishnamurti ji was basically that, and B.V. Krishnamurti ji, both were there instrumental to bring the middle atmospheric program in India. And due to that, LIDAR at Gadanki and LIDAR at Mount Abu, they were established in 90s, late 90s. So that has basically churned the atmospheric science in India and has given so many results. You see that our Venkat Ratnam ji has published more than 200 papers in last 15 years. That is really remarkable achievement by scientists from India like that. And if I am not wrong, he is having the highest number of publication that in atmospheric scientists at his age group scientists in India. So, and that major thing are based on the LIDAR, balloons, and so many instruments he has other, but major of his work is on the LIDAR and balloon and other techniques, some ground-based instrumentation. So I will be basically taking you to little different domain, but where the Professor Jayaraman ji left yesterday, a few things will be told like that, Dr. Sharma, how the LIDAR is being used for atmospheric temperature measurement. LIDAR is being like that. Relay LIDAR is being looked at atmospheric thermometer. How it will work as atmospheric thermometer, and then I will open different windows like that. What you cannot do by LIDAR. I mean to say like that, you can do whatever you think in the atmospheric science, you can do by using the LIDAR, ground-based as well as satellite-based LIDAR. So LIDAR is such a powerful tool, starting from ground up to 90, 100, 110 kilometers using the, you can say, the metal LIDARs and with Goldman LIDAR and all these things. You can use like that complete spectrum you can get. And simultaneous observation, and the beauty of the LIDAR is the unprecedented temporal and vertical resolution. It's a very few instruments are best of my knowledge. LIDAR is the best in giving the very good temporal resolution and the best vertical resolution as per your requirement of the scientific problem, what you want to study. You can tune the LIDAR to your required resolution in vertical direction, and temporally also you can do. So this much flexibility is a very little instrument. Of course, there is a limitations. I will come to that. There are few limitations, but the advantages are much more than the limitations which are associated with the LIDARs. So with this, I will start like my journey with you. LIDAR detection and ranging, light detection and ranging, LIDAR, a versatile tool to explore the Earth's lower and middle atmosphere. So before that, there is a little commercial advertisement. I would like to say here that PRL is celebrating the Platinum Jayanti or Platinum Jubilee. It has completed 75 years of its establishment. In 1947, it was established by our late great visionary scientist Dr. Vikram Sarabhai. So it is completing the 75 year, and you can say our it is going hand in hand with our independence 75 year. So India is celebrating 75 years of the independence, and PRL is basically celebrating the 75 years of its establishment. So with this, I will start like that. So little commercial, you can say. What is a PRL? You see that PRL has basically majorly 4 campuses. One campus is the main campus, which is in PRL Ahmedabad, and another campus is near to Ahmedabad, about 5 kilometers, is Haltej campus. And then 2 campuses we have in the neighboring state, that is Rajasthan. They are beautiful campuses. One is in the lake city of Udaipur. There we have Udaipur Solar Observatory, and another one as at the highest peak of Aravalli range of mountain Guru Shikhar, which is a hill station in the Rajasthan. That there we have our observatory. So we have the 4 campuses, Ahmedabad 2 campuses, and 2 campuses in Rajasthan, Udaipur and Mount Abu. So this is basically PRL, and PRL studies from deep ocean to up to the deep universe. Every field of the domain is being explored by different basically divisions and different scientists, and you can get more detail on our website by visiting our website www.prl.res.in. There you can get more detail what you can say multifaceted science is being done in PRL, starting from theoretical physics, oceanography, and we are making the payloads for satellites and planetary exploration. So many things are being done. I'll not go in that detail. So now I'll come to the topic. So that if you see the PRLs, okay, I will start that this is the beautiful PRLs observatory at you can say Guru Shikhar Mount Abu. This is our astronomical observatory, and this is our atmospheric science and LIDAR observatory. You can say this here we have the LIDAR. I will show the things in more detail as we move. Okay, and this is you can say inside the lake, beautiful solar observatory, that is Udaipur Solar Observatory in the Fateh Sagar Lake of Udaipur city, that is city of the lakes. So these are just to show you these fascinating campuses. And now I'll come to that. This is the Earth atmospheric thermal structure. You can see I'll not go in more detail. There are many things has been told to you, but if you see this, how the life is embedded into the atmosphere. So troposphere temperature decreases, stratosphere temperature increases, and mesosphere again temperature decreases, and thermosphere again temperature increases. Though we live in the basically in the troposphere, but you see the regions above it, the stratosphere, mesosphere, thermosphere, all are important to us, that they are directly or indirectly affecting to us, and they are nicely coupled. As Dr. Venkatratnam has told, na, beautiful waves are generated, and these waves are going to the stratosphere and mesosphere and breaking there. So they are connecting wires from troposphere to mesosphere. So this is basically surface to coupling, upward coupling waves. And then if you see the radiative coupling, then sun radiations are coming from the top, and they are coming to top and reaching to the earth. So there is a radiative coupling, there is a dynamical coupling, and along with there is a one more term is there is a chemical coupling. You see the ozone layer, that is full of the chemistry is there. So chemistry, physics, dynamics, all the things you can do is a beautiful laboratory is in front of you, and there are beautiful tools like LIDAR and radars. You can probe it as you desire it. Okay, you should have the thirst for probing it. You can do it. And then in layman's language, how you will say it's a lower atmosphere up to about 10 to 12 kilometers, then middle atmosphere from 10 to 100 kilometers, and then upper atmosphere. And you see that lower atmosphere is coupled with the middle atmosphere, and middle atmosphere is coupled with the upper atmosphere, and other way around, as I told. And upper atmosphere affects middle atmosphere couples the lower atmosphere. So this is like our human body. Just like our human body, if the left hand is coupled with the right hand and leg is coupled with you have pain in the leg, and then you cannot focus or concentrate, and you see the complete your body is coupled. If one part of the body is malfunctioning, then that your full body is sick. You will be told like that you are sick. So similar in the atmosphere, it is fully coupled. It's not like that if we are contaminating, or you can say we are polluting the lower atmosphere, then there is no change will happen in middle atmosphere and upper atmosphere. And now the effects are seen observationally also. Earlier there was a model prediction, but now with the beautiful data sets for 20 years, 30 years, now you can see that climate change is taking place not only in the lower atmosphere, in the middle and upper atmosphere also there are clear signatures of the climate change. And that is, as Professor German has told, like that. It is like that. Atmosphere is not a bottomless sink. It will definitely rebound. It will definitely show its Rudra Roop, I'll say. So we have to be careful like that. to mitigate these things, to reduce these things, not to disturb the atmosphere, try to make it like that as natural as possible for our coming generations. So for that, these observations are very much required, and at many places they are required, not only at one place. So with this preamble, that I think you are convinced now. This is basically focused to our young scientists, or you can say students. You are convinced that atmospheric studies are must. Okay, because we live there, and COVID has shown that only for a few minutes, if you don't get oxygen, then what will happen? I will not go in that detail. So what is the importance of the atmosphere, where we have the livable composition of the air, or that oxygen and that other components? So that how important it is. And you may be surprised, about 28,000 times in 24 hours you breathe. Food you take only 2-3 times, water you take 5-10 times, but air you breathe at least 26,000 times in 24 hours, and without which you cannot live for a few minutes. You can live without food for several days. You can live without food for a few days, but just you think how many minutes, not matter of days, how many minutes you can live without atmosphere. So that's what the atmospheric investigations are very, very much required, and as resolved as possible required, and they should be mitigated also. So the remote sensing, the beautiful basically technique. Without going there, you are coming to know about that place. That is, and there is a passive remote sensing and active remote sensing. Passive remote sensing, the example is astronomy. You are not going to the object, you are not going to the sun, you are not going to any star or planet, and you are getting the signal from there, and you are coming to know about all the physics, chemistry, biology of that star and planet. And active remote sensing, where that my expertise are there, that is LIDAR and radar. Radar and LIDAR are acronym to both radio detection and ranging, and laser basically based light detection and ranging, because laser is a beautiful source of light. That's what this is, light detection and ranging. And there you send some signal, and whatever comes naturally, that becomes noise in the active remote sensing. Please remember, when we are doing the active remote sensing, then the signal which is coming back due to our transmission, that is actual signal we desire, and whatever is naturally coming, that is noise for us in the active remote sensing. But in passive remote sensing, whatever naturally coming, that is our signal, that is we are investigating that. So this is a little difference in passive and active remote sensing. Then how these tools are being used, how to explore the lower and mid atmosphere. You know that Ratnam has told balloons, beautiful job they can do, but you know that he has shown very nicely, Ratnam has shown that they are limited by the altitude coverage, 25 to 30 kilometers, at the most up to 40 kilometers. And you cannot launch balloon every second. It is very difficult for every minute or every 5 minutes you can launch balloon for several years. It is basically practically very difficult in different places. So this is the limitation of the balloon. And then basically you can do the beautiful study up to 500 kilometers or even more with the help of rockets. But rockets are limited like that. You can do the rocketry only from the sea coast, because rocket and missiles are same. Only difference, in rocket we put our instrument, and in the missile the bomb is kept. So it is like that. It has to have the sea looking, means it should go and fell down into sea. So then from landlocked stations you cannot fire the rockets. So this is the limitation. And in the rocket you will get just a snapshot. Few minutes you will get observation. That's it. You cannot have the continuous observation like ground-based system like mesosphere, stratosphere, troposphere radar. Our beautiful radar at Gadanki, operational for more than 25 years, and it has changed the thinking of the, you can say, the atmospheric science in India. That so much contribution has come from MST radar, and now it is augmented by the LIDAR also. So both complementary, as Ratnam has nicely told. So the MST radar, but MST radar also comes with the limitation. Just remember the figure was shown by Ratnam. The stratospheric region from 20 to 60 kilometers, the MST radar basically does not give any signal, because there is no turbulence there, and it does not meet the requirement of the clear air turbulence at that in that altitude region. So that region the MST radar is blind. Okay. Then I am coming to our ground-based radar. Ground-based radar, very good resolution, vertical resolution as well as temporal resolution. But sometimes the relay LIDAR is a weather dependent. But we have countered it like that. We are studying the weather features by using our LIDAR. So now, whether it's raining, all weather LIDARs we have. We can study the cloud, we can study aerosol, we can study whatever you think we can investigate by using the LIDAR, starting from surface up to 90-100 kilometers. Okay, ground-based LIDAR. And as you know, there is a major limitation of the LIDAR is it gives the pointed observation. Spatial coverage is limited. So you cannot put the LIDAR at every 1 kilometer or every 10 kilometers. Difficult. So then you have to complement it with the satellite observation. And of course, satellite has vertical poor resolution, number of passes, and these are limitations are there. But if you combine these two, LIDAR and satellite observation, then you can reach towards completion, not complete, completion. You can beautifully get the picture of the full atmosphere and the process which you want to investigate. Because now there is a LIDAR on the satellite platform also, Calypso. This gives that so many observation of the cloud and aerosol and so on and so forth. And so this is basically suite of the experiment like that, ground-based instrument and satellite. So if you use both, then you can achieve better and better scientific goals. Now you see that pictorially how this, as I told, the radio sound. If you see here, that radio sound launch are there basically. Radio sound. You see, the radio sound are covering 20-25 kilometers. Then stratospheric balloon up to 30-35 kilometers, and rockets middle atmosphere up to lower atmosphere like that. But you see the LIDAR green one beautifully up to 100-110 kilometers. It covers full spectrum by using the different type of LIDAR. Okay, and even not only this, you can study the nucleus cloud. You can study the polar stratospheric cloud. These all you can study by using the different types of LIDAR. I will come later what type of LIDAR. So LIDAR, it is a word of LIDAR, light detection and ranging, beautiful. This is Mount Abu Observatory. These are our mobile LIDARs. And then I say the system can be used to study temperature, ozone, water vapor, cloud, sodium, potassium, boundary layer, whatever you think you can investigate by using the different type of LIDAR. Now, if you see that what type of LIDARs we have in a PRL or in India, you can say, so that this is the middle atmospheric LIDAR, which was established in 1997, almost same time when that middle atmospheric program was there. And as Professor Jarmanji has told yesterday, that it was used for Peanut Abu eruption in Ahmedabad first, and then with the bigger telescope, it was shifted to Mount Abu Observatory in 1996. And from 1997, we have the regular observation. And you see, since 1998, we have regular observation in Gadanki. So we are completely like that. We have beautiful tropical location and subtropical location. I will come little later to this. So this is the Mount Abu, the snapshot of the Mount Abu Observatory. We have the two telescopes. This is for lower atmospheric clouds and aerosol study with using knee LIDAR, and this we are using for Rayleigh and Raman LIDAR. This is 90 centimeter telescope and laser, and of course this is inside view of our LIDAR laboratory, which we set up about 2 decades before in 1997 over Mount Abu. So this is being used for different kind of studies, and mostly we are using it like that, aerosol, cloud and middle atmospheric investigation, which are very beautifully we get because we are situated at height of about 1.7 kilometers. So we can probe the higher heights by little less power in the LIDAR. And then we have the portable LIDARs, which are giving the clouds and boundary layer information. These are kilometer, and we are making it work in the India. Recently, basically few years back, we have added another feather in PRL's, you can say LIDAR suite, that is India's first multi-channel Raman LIDAR. It has the 7 channels, and to the 7 channels, it is a porta cabin type lift and carry type of. This is situated in the PRL campus, lift and carry type of system. You can lift it and carry somewhere. You can carry to ship. You can carry to other place. This type of system is there. This is to study the atmospheric temperature, water vapor, troposphere, stratospheric change. This basically covers altitude range up to 20 kilometers. So this is basically, and the beauty is 7 channel. So we have dual polarization at 355 and at 532. I'll come a little later in the detail of this. So these type of LIDARs, we have that in PRL, and if you complement with that even Gadanki, then we have, you can say in India, ample opportunities are there for the students who want to do the LIDAR science or even atmospheric science using the LIDARs. So again, once again, you see that beautiful picture of our observatory. This is, you can say, this is outside view of our LIDAR observatory at Mount Abu. We have even ionospheric passive remote sensing instruments also, and this is our LIDAR and LIDAR lab is shown here. And this is basically nighttime view. We have basically 3 wavelength. We have the 355, we have 532, and we have 590 for sodium. So you can see this is a 532 green line pumped into nighttime. You see at Mount Abu LIDAR, and this is so Rayleigh Raman LIDAR we are using by this green light 532 nanometer, and the sodium LIDAR by using the 589 nanometer wavelength. So this is these are the 2 that beams are going into beautifully into the sky to probe atmosphere up to 90 kilometer or even little above. Sometime when seeing condition is very good. This is just to show you. This slide I will take 1 minute, and this is very good for the students, not for the expert. Here you see that different types of lidar. So lidars has been named on what? Those, so lidars are named on that what process they are using for the detection of the entity, what you want to detect. So which process is being used. So that if you see here, this first column, what is shown here, this is physics. What is the physics? And this is the system. This is the instrument. What is the instrument? And this is basically what is deliverable. What we are giving to the society. What science we are using. What is the, so you can say there is a physics scientist, this is engineer, and this is society. So all three are sitting together, science, engineering, and society. All three are coupled. So you see that elastic scattering by aerosol and cloud, that is me lidar. Me scattering yesterday was beautifully told by several of our Professor Jaramanji, Veera, and all told us me lidar. And me lidar used aerosol, cloud, geometry, thickness, and so many things. Then very beautifully talked by Virbhuti and Dial, differential absorption lidar, and by our Raghunathji. That differential absorption lidar which is being developed at Gadanki. So it is absorption by atoms and molecules. So I will not go in that detail. It gives gaseous pollutant, ozone, humidity, etc. by differential absorption lidar. Then if you use the inelastic part of the scattering, that is the Raman scattering. You use the Raman, I will come in detail. So by using the Raman lidar, you can do so many things like the water vapor profile, aerosol, cloud, optical density, and most importantly, if you see the temperature into the lower atmosphere, because the mean lidar cannot give the temperature in the lower atmosphere due to possible contamination by the aerosols and clouds. But with the Raman lidar, you can derive the temperature in the lower atmosphere. So this is the beauty of Raman lidar. Then I am coming to our workhorse like Gadanki and Mount Abu. Both the places we have beautiful relay lidars. And relay lidars are using the elastic scattering by air molecules. Air molecules, I mean to say like that nitrogen, oxygen, CO2, argon, etc. Like that. So this is from neutral atmosphere, where the neutral atmosphere is being probed like elastic scattering. And as Jaramanji has nicely explained, relay scattering takes place when the size of the scatterer is much smaller than the wavelength. And the mean scattering when it is equal to the size of the scatterer is equal to almost or bigger than the wavelength. He has shown very diagrammatically nicely, you may remember it. So that I will not go in that detail. So that is a relay lidar is being, and relay lidar is used for stratospheric, mesospheric density, temperature, wave, and dynamics, everything you can study. Okay, that's what by using the relay lidar is known as atmospheric thermometer. Simple thermometer will not work beyond certain altitude because it measures the kinetic temperature and density is very low. So you have to devise that technique, and that is a relay. With the relay lidar, you can derive temperature up to 90. Above that, if you derive, it will be erroneous because the condition which we are using, the hydrostatic equilibrium and ideal gases, that fails there. That's what we say, safely up to 90 kilometers, you can derive the temperature using the relay lidar. So that is full atmospheric thermometer. And if you combine it with the Raman lidar, then you will get from bottom or from surface up to 90 kilometer full temperature you will get. Okay. So, and then I'll not go in much detail like resonance, fluorescence lidar, then wind lidar, Doppler wind lidar. Raghunathji has yesterday very nicely explained that Gadanki's wind lidar, that you work on the Doppler shift measurement, that winds in the stratospheric region, very difficult to measure, and it is being measured now in our tropical region, our Gadanki. And then fluorescence lidar, then laser rangefinder, laser altimetry. So you see that there is a beautiful basically application of the lidar, not only in the science, even if you go just little from society to science, then also is like say laser rangefinder, laser altimeter for measuring the depth, and all these things being used. I will just touch upon. And these are what like that wind, turbulence, varied vegetation, topography, and target. So using the science, use the type of lidar which you want, and then you can study what you wish to study by choosing the particular lidar. So with this, I will move little faster. One thing yesterday that Jaramanji has very nicely explained how lidar works. One thing is like that many students want to know that how lidar keeps the vertical information, how it gives information from different altitude. So for that, I have made a small cartoon. It's like that. It is like that. When you start the lidar, then the atmosphere is divided into the different layers, just like slices of the bread. Okay, the atmosphere is sliced like slices of the bread, and this thickness of the slice you can choose. Thickness of the slice means that vertical resolution you can choose by your instrument setting or experiment specification file, ESF file. You can choose this how good resolution you want. So these are the resolution. This suppose your atmosphere is divided into this. Then what you will do, that receiver channel are made into our receiver automatically with the shift registers or counters. So this accordingly the receiver channels are made. Fine. And then if you pump the laser, you see, and what range bin I have kept here, it is about 96 meter. About 100 meter we have kept, and 100 meter corresponds to 640 nanosecond in LIDAR and radar terminology. Okay. So this is if you put the time difference 640 nanosecond, then automatically it will select the time altitude 96 meter. So this is atmosphere now you can say, and this is the ready channel, or you can say ready receiver for getting the information from different altitudes. So if you pump the laser beam has gone into the sky, then what will happen? When the laser beam is here, then the signal what is coming from first layer will be kept here. Then suppose laser beam reached here, then whatever excitation or backscatter signal will come, it will be kept in range bin number 3, and then it will be kept in range bin number 6, and so on and so forth. So you see beautifully you will get the vertical profile. I will show you next one. Again, I will play this. You see that first you divide the atmosphere into the different, you can say, thickness slices, what you desired, 100 meter, 10 meter, 50 meter, 500 meter. And then accordingly the channels are made into the receiver, which is at the receiving side. And then you can select the range bins, whatever range bin you have selected, pump the laser. And when the laser enters into the atmosphere, whatever signal comes from particular range bin, it is kept in the particular bucket, or you can say particular shift register, or electronically set on this place only. So thus you know this height corresponds to this channel. This height corresponds to this channel. So that way you know that how many photons are coming from which altitude. And these photons in the relay LIDAR are directly proportional to the atmospheric, you can say, the constituent R density. Whether it is aerosol, clouds, or whatever the backscatter signal is coming. So you see these are like that, from different altitude are coming, and they are kept in the different buckets. By that you will make the profile. How the profile look like, you see actually. One more thing yesterday, that how the temperature is being derived by using the relay LIDAR, that was also left by Professor Sharma sir. He told that I will be talking more in detail, so I'll just take little time. So this is basically LIDAR equation. I will not go into that detail. For a given LIDAR system, if you see, the density is basically everything. This is for given LIDAR
sir,
system.
excuse me, sir.
Yes.
Sir, last 10 minutes, sir.
Okay. Sorry. Sorry. 10 more minutes. Hello. Okay.
10 more.
Okay. I'll just go a little fast. Okay. So that you see the density is directly proportional to the basically the LIDAR signal which is being received. And then by using these two equations, hydraulic equation and ideal gas law, that by using this you can derive the temperature. And this temperature is being derived through pressure by fitting the model pressure. So that temperature beautifully you can get from basically from 20 kilometer or 25 kilometer, which is free from the aerosol, up to how it look like that. You see, this is the raw signal here. Raw signal, you see this channel number, and this is the signal. Then you can basically normalize it and do the correction, dead time correction, etc. Then you can get the density profile, and from density you can derive it. So LIDAR directly does not measure the temperature. Please remember, it gives the density, and from density the temperature is being derived. And then as I told that how the Rayleigh and Raman signal, lower atmosphere and middle atmosphere. So this red signal is from basically Raman LIDAR, and the green one is from Rayleigh LIDAR. Both are range corrected and both are combined together. You can see like that, this is Rayleigh Raman combined profile of the density, and from that density the temperature is derived. So this is just to show you that. Now, as you know that our LIDAR, Gadanki and Mount Abu are contemporary, so that we are almost having the more than 15 years of good quality observation. So you see, this is basically the stratospheric temperature, stratospheric mesospheric temperature over Gadanki, and these are stratospheric mesospheric temperature over Mount Abu. The difference is Gadanki falls in the tropical region 13.5 degree north, and the Mount Abu falls in the region of the subtropical region. So you can clearly see the difference between the tropical and subtropical region by using the LIDAR temperature after the climatology. Then, if you go event by, this is our work with the Professor Kumar, who is here in nowadays in South Africa. So we did the work together. So that same day, 24 of April 2001, you see this is our joint paper. So this you see the stratopause structure. beautifully at both the places available. MTI, both the places available, only height difference is there. Not only this, if you see that we have done the power spectrum analysis of series of the data, then you can see that from stratosphere and mesosphere over Mount Abu and stratosphere, mesosphere, power spectrum over Gandaki, how they are different in the vicinity. So there are similarities, then you see differences climatologically, event wise, there are sometimes similarities, and then again, if you see the day wise, how the things are changing, that studies has been beautifully done by in our collaborative studies with the Gandaki and Mount Abu. And then you see the mesospheric temperature inversion, as Venkatratnam ji has told, and other also. So beautiful, up to 40-degree temperature inversion we have got. We see the perturbation in the wind through satellite, and why it is there? Because Mount Abu is giving the beautiful, basically, platform for generation of the wave. And we say that wave generated in the lower atmosphere go and break and increase the temperature at that altitude. And of course, the chemical reactions cannot be ignored. So this is mesospheric temperature inversion. Then you cannot left alone the ozone as a chemical coupling, as I told, in the atmosphere. So how the stratospheric temperature is associated with the ozone, that you see over Mount Abu. This is the ozone from the tombs. This is the stratospheric temperature by the LIDAR. And then if you make the harmonic analysis, you will find they are going hand in hand. So the minimum ozone in the winter months, and we have the minimum temperature in the winter months in the stratospheric region, and they are very having a good correlation, the ozone and temperature. Then one very beautiful study we did using the satellite and LIDAR over Indian sector, how the SSW changes the pattern from 35-degree north to 5-degree north. If you go from India, you can say the northern region to the southern region to the oceanic region. Here you can see the beautifully how SSW changes the altitude of the stratosphere and then structure of the stratosphere. I will not go in that detail. You can see the detail in that paper. So in India, from 35-degree north to 5-degree north, how stratosphere changes during the stratospheric sudden warming event, then you can see beautifully, and what are the structures and how it is elongated. And then later on, we did the power spectrum analysis and other things has been done. That paper has come again in PRL with my student Priyanka. Okay. And then, as it was told just now by Venkatratnam, there is a signature of stratospheric and mesospheric cooling in accordance or in continuation with the global warming. Because if there is a warming somewhere, there should be cooling somewhere, because energy should be conserved. So by using the halo observation, LIDAR observation, SABRE observation, that very clearly you can say there is a clear tendency of decreasing temperature into the stratosphere by 3 independent, you can say, the 2 satellite and 1 LIDAR. So the temperature is, although mesosphere and stratosphere is cooling. Okay, and now we have longer data, so the errors are constant, so we can say the confidence level is high to get the climate change effect in the Earth's middle atmosphere. Now I'll just switch the gear and quickly I will go to the LIDARs, which are not weather dependent, all weather type of LIDAR, and that is basically a study of the cloud. I'll not go that. This is a beautiful study of the cloud over Ahmedabad. You can see that how the rain is associated with the cloud updraft and downdraft. This type of study has been done. Then pre-monsoon, monsoon and post-monsoon type of cloud in the western region of India, how they play the role in the radiation budget as well as in the rain, bringing the rain, and then normal rain, heavy rain and no rain, how the cloud. So the x-axis is time and y-axis altitude of the cloud, cloud top height from satellite and cloud bottom height from our LIDAR. Okay, that's kilometer portable LIDARs. So that you can see the beautifully no rain, heavy rain and all these things we have done. You can see the detail in these papers. And then, as I told that from bottom of the, you can say, surface of the earth up to 90 kilometers in a study, we have studied the fog over the Delhi region. One of my students, he's now in IMD, he studied the fog events over Delhi region by using the LIDAR system, and we have found the beautiful result about the fog and low level cloud, and then we try to calibrate it, the inset observation. These are there, and these are published in a couple of papers. You can see these in recent past. Okay, and then as I told that we have augmented our LIDAR kitty by India's first multi-channel Raman LIDAR. What I will say multi-channel, it has a 7 wavelengths. That is a beauty. You are looking the atmosphere by 7 channels together or 7 eyes together. So you have basically opportunity to study the different processes which are taking place simultaneously. So this is a multi-channel PRL's Raman LIDAR. With this, I will show like that the Raman technique, you know that strokes and anti-strokes shifted towards the red and blue direction from the excitations. And this is the basis for Raman LIDAR. And you see that all the components are here. If you pump with 532, then oxygen, nitrogen will go 580, 607, and then H2O molecule, then 355, 266. These are excitation wavelength. These are Raman excited wavelength with the different basically pumping wavelength. This is a pumping wavelength, and these are from different, this is from O2, this is from N2, this is from water vapor, and so on and so forth. So this type of investigation you can do, vertical distribution or vertical profiling you can do by using the Raman LIDAR, what I have showed just a minute ago. And then this is a cloud and boundary layer interaction by the Raman LIDAR. You can see the beautiful structure of the boundary layer and how the cloud is sitting over the boundary layer like camel hump. So the Raman LIDAR observes the cloud sitting over the top of the boundary layer, and this paper is basically I forgot to update, soon it will be appearing in the AR. Okay, so this is this type of investigation, and then this paper has already come, that one of my colleagues like that we have worked like that in atmosphere research. The first investigation, comprehensive investigation of boundary layer, you can say 24/7 for a few years like that. So you see that how the boundary layer is changing from the day to day over Ahmedabad. And you see that the down type of thing is like in first February, third February going down and going up. So this type of things are being done. Then how the monthly variation of the boundary layer are then the very beautiful investigation. And then winter summer differences over in the boundary layer over Ahmedabad. And then last thing is there, I wish to talk that there was a very beautiful cirrus cloud structure was sitting, and it was intruding from in India from the Arabian Sea. You see, this was the beautiful structure inside picture. And that you see that as we need, as Ratnam also has emphasized, we need the observation over the oceanic surface because we are missing this. And luckily we have that observation over Mount Abu, the Raman LIDAR observation over, over Ahmedabad, and we could study at least some part of this cirrus cloud structure which was sitting like this. And that basically paper came in the GRL. You can see that this how a new finding, how the cirrus cloud crystal structure is tampered with the gravity wave propagation. I will not go into that detail. You can see this beautiful structure, and this is a LIDAR observation over Ahmedabad. This is a first of its kind study where the ice crystal shape and size has been modulated by the propagation of gravity wave. You can see that how clouds are introducing by meteor set. This is a basically inset observation. And then lastly, we cannot leave alone the COVID. You see that during COVID town, this is like the boundary layer situation during no lockdown. April 19, then April 20, you see complete lockdown, and then the state restriction. So you can see how the boundary layer, these empty boxes are there, full empty and half empty. So this type of investigation we did, that papers are soon will be coming like that, how the COVID has changed the atmospheric conditions, boundary layer, cloud cover, and the dust in the atmosphere. These all the things has come. This is by submitted. So soon you will see that paper. And then this already I discussed. And not only this, you can do the aerial, because if you put the LIDAR in the our platform on this thing, so then you can beautifully study the canopy of the forest. You can study the forest canopy. You can greenery, vegetation. These are all the things you can do by the LIDAR. You see, this is the ground elevation. This is canopy. You can do beautifully by the aerial LIDAR survey. You put the portable LIDAR in the aircraft, and you can do this time. So LIDAR, not only in atmosphere, in the forestry, in agrometry, in botany, everywhere you can use the LIDAR, which type of study you want to do. So the word of LIDAR is a very big, and with this you can see, even you can say count the leaves, or you can say with leaf, without leaf, with the help of LIDAR, because the resolution is very good. Basically the vertical resolution is very good, so you can study this type of, this is not my work, just I want to introduce to the newcomers like that there is an ocean of opportunities by using the LIDAR to investigate the different type of processes in the earth atmosphere, in the forestry, and where you want to use this, even in planetary atmosphere, you can use the LIDAR for investigation of different things. And then I would like to emphasize that you can say that more than 20 years, the relay LIDAR are operational, very few around the globe. More than 20 years, please remember. So these are basically high altitude. This is OHP, this is Mauna Loa, and we are lucky to have two in the India. One in the tropical region, one in the subtropical region, and then of course Reunion, where Shiva is sitting right now. That is a longer observation are available, and these are very much required. I wish and pray that more and more these stations which are probing up to middle atmosphere should be set up and permanently should be operated for longer period to address the issue of the climate change, as has been highlighted by our Dr. Venkat Ratnam. So this is basically India's situation. We are lucky to have two. And then last I will say like that I am involved in like that a project, PI of this project. I am setting up the Indian LIDAR network, and in Indian LIDAR network we are putting the portable boundary layer, cloud, and aerosol network. So we have set up many LIDARs, 8-10 LIDARs in the northern India, and next week I am going to put in the Leh. And then I think in coming years when budget will come, then we will be putting the places where like that the requirement is there and where already there is no LIDAR. So this is my plan to bring out the comprehensive pan-India network of the LIDAR along with my colleagues and collaborators. in different laboratories, different ISRO centers. I'm thankful to all of them. So this is for future, and all the future young scientists are having opportunity to work on this type of things. And then future outlook, I will not read. Long-term observations are required at different locations to get the trends, tropical and subtropical middle atmosphere OND region, cause and consequences. And most importantly, coordinated campaigns are very much required, because one person, one laboratory cannot go everywhere, cannot work, basically cannot give the comprehensive results. So for that, it is required very beautiful, or you can say the cordial collaboration should be there, and with the collaboration, we can cover the full India, and we can do like that. Last, I'll say like that, this is satellite sensors, for calibration of satellite sensor, for tuning the model, as Ratnam has told, because model required ground truth input for giving the better prediction. And lastly, for the useful for the policy makers. Okay. And with this, I will say thank you very much for patient listening. I am sorry for taking little more time. And I'll say like that, we should be collaborating with the Indian partners as well as for the international community to bring out the comprehensive atmospheric science from India in better and better. Thank you very much for your presentation.
Sir, thank you very much, sir. Thank you very much, sir, for your illustrative and very detailed explanation about LIDAR observations over Mount Abu. And quick, any one question from the audience. Mike. Mike.
Hello, sir. I'm Hemant Kumar.
Yes, Hemant.
Sir, is it audible for you, sir? Kumar,
yes,
sir?
yes. You are fully, clearly audible. Please go ahead.
Hello.
Yes, please ask your question.
Yeah. Sir, I need one small clarification.
Yes.
So, what about the Raman LIDAR? Is it in Mount Abu or in Ahmedabad?
No, it is in Ahmedabad. It is not in Mount Abu. Basically, it is located in PRL Ahmedabad campus, not at Mount Abu. Because Mount Abu, we have another big LIDAR which we operate in all three modes, Relay, Me, and Raman mode. But in that, we don't have different channels of the Raman because it is single channel. But the LIDAR at Ahmedabad, that it is basically Raman, that's 7 channels. So we use it for water vapor, cloud, boundary layer, aerosols, etc. And for polarization estimate. Some echo is coming.
So majority of the aerosols or whatever the humidity would be.
Sorry, I could not hear your question. Can anybody repeat it? Can Vishnu please you?
Sir, here power just now shut down, sir. So that's the thing.
So can you repeat the question? What he asked?
Yeah. I will just hand over to him, sir.
Actually, here the power has lost.
Yeah.
So that's why I'm connecting from my mobile.
No problem. Through mobile, you can ask the question. You are audible.
Yeah. Actually, that was my doubt, sir. Because majority your LIDAR, which is in Mount Abu, is at 1.7 kilometer.
Yeah.
So I thought if it is there, and majority
but
of
Mount Abu LIDAR, because we have suite of LIDAR, I showed the first slide. Now we have Mount Abu LIDAR, then kilometer LIDAR network we are making, and then Raman LIDAR at Ahmedabad.
Yeah,
That's right. I showed the LIDARs at PRL. So in Mount Abu, we have LIDAR that we operate in Relay, Me, Raman, and Sodium. Okay. And I showed the beam. And then Ahmedabad LIDAR, we like that. We have that is only Raman LIDAR, and that is for altitude only up to 15 to 20 kilometers. But Mount Abu LIDAR up to 90 kilometers.
Okay, sir. Thank you, sir. Sir, one more question from another participant.
Yes, please.
Yeah, Prasad, go ahead.
Sir, very nice presentation, sir. Hello?
Yes, I'm hearing.
Sir, I have one doubt while estimating the boundary layer with LIDAR observations, especially.
Yes.
Because in the LIDAR observations, when we're estimating the boundary layer, aerosol is considering as a tracer.
Yes.
Suppose we have 2 LIDARs. One is at maybe like urban location where heavy polluted. Right. Suppose in another LIDAR is opposite rural, like low polluted.
Okay.
Suppose when you're considering that is an aerosol layer,
yes.
Suppose it is nearly 2.5 kilometers. Suppose it is in urban location. It is in that rural. Suppose it be no layer. No, maybe it is limited to 1 kilometer. So
Okay.
whether we are considering this is, which one is the boundary layer, then how it will be, we address that LIDAR is giving that boundary layer is exactly whether 2.5 or 1 kilometer, how far it will be vary in that aspect.
Yes, your question is very nice question, Prasad. Very beautiful question. Basically, these are the some limitations of the systems. Okay, because you know that derivation of the boundary layer is a very complex and tricky process. Okay, because it is highly variable from place to place, region to region, and season to season. So then what you need to do like that, it is like that. At the place where the urban location is there, and you know that the urban locations are having little higher temperature. So definitely always the boundary layer is situated at a higher altitude than in the remote location, because it is temperature driven. It is temperature driven mostly, like most important parameter is temperature and convection driven. So then you need another complementary observation. Okay. So by that you can calibrate these things. Suppose you are setting the system at one place which is very clean and one which is very polluted. That's what we are making the network. And then we will be using the other technique like model, satellite, whatever way we can get. It's very difficult to get the boundary line information. So these are the first ever observation which you can say over Ahmedabad, it is urban polluted location. So your question is very well, basically very nice question, but there are limitations. This is, I will say, it is a limitation, but it need to be complemented, or you can say need to be corroborated with the other observations like that, the flux tower observations now. So with the flux tower observation and other things need to be added that. Then you can say for sure. Okay. So very nice question. Thank you.
Okay, sir. Thank you very much, sir. Kumar, sir, for your clear-cut explanations and detailed presentation.
Okay, thank you, Vishnu. Thank you, Roja, and thank you all the participants for listening me properly. And I think I took few more minutes. I'm sorry for that.
Sir, no problem, sir. It's no problem.
Okay, great. Yeah.
No problem.
And I am telling the participant, I am putting my slide like that. If you have any more query and question, because I am not available there physically, but you can write me an email. My email address is I am just showing you on the screen, so you can note down my email ID. And with this email ID, you can communicate to me and you can write to. My email ID is somkumar@prl.res.in. So you can write me your queries, question, comments on my email, and I will try my best to reply. It may be little delay. I will be on tour next week, but I will definitely reply to. My email is somkumar, my first name basically, and prl.res.in. And even on website, you can PRL website, you can get me in the space and atmospheric science division. If you go in the space and science division, then you can get my email. Okay. So this is open invitation. If anybody could not ask today, so then you can ask and interact anytime whenever you need. Thank you very much.
Okay, sir. Thank you, sir. Thank you, sir. Okay. Next presentation will be Dr. Ravi Kiran, scientist, National Atmospheric Research Laboratory, will deliver a lecture on LIDAR technology.